So today we're going to look at completing the square, which is a method of turning a quadratic equation in standard form into a quadratic in vertex form. Now, the reason we would want to do this is that standard form doesn't give us a whole lot of information the way that it is, and we have to do sort of a lot of manipulating to find certain things like the location of the vertex, or we use complicated formulas to find the location of the vertex. Whereas vertex form is a lot simpler. We have our P and our Q right there ready for us, which tells us the vertex, then tells us the equation of the axis of symmetry, as well as the max or min value here, and the direction and width of the opening. So we can get a whole bunch of information a lot more easily from the vertex form. So sometimes we'll want to convert from standard form into vertex form, and we do this by this thing called completing the square. So what this means is that we take whatever is in here and we want to somehow turn this x squared minus 8x into a perfect trinomial that we could then write as the square of a binomial. So what I mean by that is that if you square a binomial like x minus 2, for example, you square it, x minus 2 times x minus 2, you get x squared minus 4x plus 4. So you end up with a trinomial. Now this is a perfect trinomial, so it can be written as the square of a binomial, obviously, because we just expanded a binomial to get it. So that's what we want to do here with this x squared minus 8x, so whichever terms have the x's in them, we want to try and take those and turn them into a perfect trinomial that we can then turn into a binomial squared and make it look like this. So basically we're taking this, we're trying to find this to turn it into this so that we can turn it into this, and then we'll be done converting from one form to the other. So let's see how that's done. Now there's a nice little set of steps here that will make this easier for us. First thing we want to do is we only focus on the first two terms, the things that have x's in them. And what we're going to do is we're going to take exactly half of this, so the linear term, so the coefficient on the x, so we're going to take half of it, so divide it by 2, and that will give us negative 4. Okay, so negative 8 divided by 2 will give us negative 4. Then we're going to next take that number and we're going to square it. So this is the next step, negative 4 squared, and that equals 16. Now, since we're not allowed to actually change the equation at all, if we decide to add 16 into this equation to make this thing a perfect trinomial, like this is a perfect trinomial now. We've added 16 to the equation, but we're not allowed to change it, so we have to then go ahead and subtract that same 16 so that we haven't changed the equation at all, right? So we've added a 16, subtracted a 16. So essentially if you took this out, you would be left with x squared minus 8x plus 5, which is the original equation. So the important thing is that we don't actually change anything. Now, these three things, and the reason we've chosen this specific value of 16 is so that we can write this as this perfect, or the square of a binomial. So what we do now is we take this same value that we had before, and that becomes the p-value that goes in our binomial. So this whole thing here, this trinomial, turns into x minus 4 squared. And if you want to double check, you can go ahead and expand that and see how you do, and you should end up with exactly this. And then what we're left with over here is negative 16 plus 5. So negative 16 plus 5 will of course leave you with negative 11. And now you can see we have this in vertex form, because we've got our p-value right here, which is 4, our q-value right here, which is -11, and from there you can obviously start to find some valuable pieces of information from this. Okay. So, if you're a person who likes algorithms, let's go through these steps. Step 1, identify the linear term. So, the linear term is the one that's just in front of the x, not the x squared, that's the quadratic term. The one in front of the x is the linear term, and then the other one is obviously just a constant. So identify the linear term. Step 2, divide it by 2. So divide that linear term by 2. Step 3, square that sucker. So we've identified the linear term, divided by 2, squared it. Step 4, add, that's an A, and subtract, so that we don't change the equation. So add and subtract the result to the original function. And then step 5, take first 3 terms and write as a binomial, which is 2 terms inside of the brackets. Write it as a binomial squared. And then step 6, if you like, simplify and call it a day. Alright, so let's get some practice working with this algorithm. So let's say we start with something that looks like this. Y equals x squared plus 6x plus 5. We want to convert this thing into vertex form. So, as the steps say, step 1, identify linear term, right here, 6x. Step 2, divide it by 2. 6 divided by 2 is 3. Step 3, square it. Good grief. 3 squared is 9. Step 4, can I delete that page? Awesome. Step 4, add and subtract the result to the original function. So now we have 9, so we go x squared plus 6x. So we add the result and subtract it to the original function, just like that. Add 9, subtract 9. Awesome. Step 5, take the first 3 terms and write as a binomial squared. First 3 terms give us a trinomial here. We can write this as a binomial squared, and again, I didn't mention it in the steps, but this will always be the number that you write in the binomial. So, x plus 3 all squared. And then that takes care of the first 3 terms, and then step 6 is simplify, and you're done. -9 plus 5 will give us -4. And you're done. Awesome. So let's try another one. This is going to look a little different this time. And you'll see why in a second. 3x squared minus 12x and minus 9. Now here we have an a value that is not 1. So we haven't looked at a case like this yet. So basically what we need to do is we need to get our 2 terms that contain variables in them to look like this with no coefficient in front of the quadratic term. So we are going to just factor out that 3 and rewrite those first two terms. So we take a 3 out of only these first two. So 3x squared divided by 3 is just x squared. Negative 12x divided by 3 is negative 4x. So we've only taken it out of those first two terms, and we leave the constant term alone. Always leave the constant term alone. Now we can begin with the regular steps of our algorithm here. So identify the linear term divided by 2 and square it. So here's your linear term, negative 4x, divided by 2. So we only worry about the coefficient. We don't need to worry about the variable here. So divide the coefficient by 2, which gives us negative 2, and then square it, which gives us 4. And then add and subtract that to this thing inside the brackets. So x squared minus 4x. Now we're going to go plus 4, and then we're going to go minus 4. And then, again, we've left the constant term alone. Now, of course, these first three are the only ones we're able to turn into a binomial squared. And again, it's going to be this value that we found early by taking half of the linear term. So it will be x minus 2 all squared. Now that takes care of the first part of it, but this negative 4 was still in the brackets to be multiplied by the 3, so we can't forget about that 3 out front. So then simplify by multiplying this in, and the first part we just leave as 3 times x minus 2 squared, but then the 3 gets multiplied by that negative 4 and gives us minus 12, and then minus 9, and then simplify at the end there. Minus 12 minus 9 will give you minus 21, and now you're done. So that's how you deal with an a value. There is a your turn on the bottom of page 186. So I want you to take your time and go through all three of them, A, B, and C, and then hit pause, and when you come back, the answers will be here waiting for you. Okay, so look through these solutions, hit pause. Hopefully you were able to get the right answers. If you weren't, then take your time to study my responses here and try to figure out where yours have gone wrong and remedy that. Good luck with the assignment, and I will see you in class tomorrow.